Viewers, you're welcome to another episode of Data Analytics with Python. My name remains Vincent Hope, your instructor. Today, we're going to be looking at one of the prediction models used for predicting values based on certain assumptions. Now, that model is called linear regression. So the topic today is actually linear regression analysis. Now, for those of you who may not have an idea of what it means, I'm going to give you a background knowledge of what linear regression means, and so that you can understand what it is used for. So let me jump right into Microsoft Word so we can have an understanding. Now, this is linear regression. Now, we start with the term regression analysis. What is regression analysis? It's a method of finding the relationship, this is important, between two variables, and those variables are independent variable, which is on the x-axis. Where is the x-axis? This red axis here is the x-axis, and the dependent variable, which is on the y-axis. This is the y-axis. Using a straight linear line. What does that mean? Now, we want to find, if you want to find the relationship between 2 points or points on both x and y axis, you use this prediction model called the regression analysis. What does that mean? Now, look, this is a point here. This point here is a point here. This point here. Now, if you notice, it has an x value. That is why there's a dot down there. It also has a y value. That's why there's a dot here. So when you are trying to examine the relationship of these points, both on the x and y axis, you are talking about linear regression analysis, and we use a straight line is used to define the relationship between several points. This is just a point. Now let's make progress. Now we said it is said that in linear regression, it has a positive relationship. We say this happens when an independent variable, which is the one on the x-axis, increases. It says when the independent variable increases, the dependent variable also increases. What does that mean? In a positive relationship, as this is increasing on the x-axis, the value of the y-axis is also increasing. Now, let's take an example of all those points we have. If you notice that this point here, it's somewhere here, then this other point here is also here. Now, if you discover that this point has increased here by the y-axis, by the x-axis, sorry, it has also increased here by the y-axis. The same thing goes for this point here. It has increased on the x-axis because the increase is by your right-hand direction. Then it has also increased here on the y-axis. So you said that these points have what is called a positive relationship, and the linear, which is the line, straight line that determines that which we use to determine the relationship, is this line here. You can see the line is going up this way, increasing in this direction. So let's take a simple table. Now we have work hours on the x-axis. We have rest hours on the y-axis. The assumption is if somebody works longer, he rests for a longer time. Now let's take an example. Now the person starts by working for 8 hours, he or she rests for 4 hours. He works for 9 hours, he rests for 5 hours. That means he has an increased rest. He works for 10 hours, he rests for 6 hours. This is just an assumption. So this kind of relationship, which is shown in this graph, is called a positive linear relationship. Now let's make progress. Now, now we have a negative relationship. So this happens when an independent variable increases, the dependent variable decreases. What does that mean? Now, remember the variable is increasing in this direction. Now, look at this point here. The variable is increasing. Now, look at the point at which it is meeting the x-axis, the y-axis here. Now, it is increasing in this direction. Now, it has increased. This point has increased on the x-axis. But on the y-axis, which is on this point, it is decreasing. Then here too, it has increased to this point here. It also, if you trace it down to the y-axis, it has also decreased. So this kind of relationship is called a negative relationship. Now, what does that mean? Let's take an example. X work hours. The person works 8 hours. His rest hours is 6 hours. He works 9 hours. His rest hours reduces, which is 5. He works for 10 hours, the rest hours reduces to 4. So this is a negative linear relationship which is found by this regression line. Now, let's go to the linear regression analysis prediction. Now, regression analysis prediction, you say using the sample data to train the X variables, which the X, train your X, so that you can predict the values of Y. Let's take a simple example so that you can understand what we're talking about. Now, let's take, for example, you say the X work hours is 10, the rest hours is 6, 9 is 5, then 8 here is 4 hours. Now, these values of X, the corresponding values of Y have been determined. Now, the idea of regression analysis is that if you have these 3 values, these other values of X, 7, 6, 5, can be predicted for the values of Y based on the previous values of Y that corresponds to X. Let me explain. I think that is clear. So we have got the value of 10, 6, 9, 5, 8, and 4. Now, what is the value of 7? What is the value of 6? What is the value of 5? That is what linear prediction does. So the model is supposed to predict what the values of the corresponding values of 7, 6, and 5 should be. Now, finding the regression line is simply finding the line that fits through all the points so that a prediction can be possible. Now, let's look at it again. Now, these are some points on both the X and Y axis. Now, you find a straight line so that is closer to all the points, in the sense that if you take a point from here, let's say you take a point from here, this point here, we take a point here, example where this cursor is now, and I draw it down, which comes to somewhere to this point, means that from this point here, I should be able to predict what the Y value is on the Y axis. So now let's go to Python so that we can see how we can do this in Python. So we go back to Python. So this is linear regression. So what do? The first thing is to load the required libraries and add empty cast data set. I've told you how to add that empty cast data set. You just go to add input, you click data sets, and you type empty cast. So these are empty cars there. You can see this has been added. So I've added this. So as usual, we add the matplot library inline, import numpy as np, import pandas as pd, import matplot library, import matplot.pyplot as plt, import operating system. Then the operating system list directory. When we list this directory, because we've added empty cars, if we run it, we discover that we have a CSV file, emptycars.csv. Now we want to display and see what is inside the empty cars, just for the purpose of knowing the content of the file. So we'll say empty cars, under empty car, under input, under cargo, we pass it using the p.read CSV into empty cars. Then we display it with empty cars.head. We run it. When we run it, these are the values there. So we have the model of the car, the miles per gallon, the cylinder, DSP, HP, and the rest of it. Now let's make progress. Now, so if we want to plot, we'll plot a scatter graph so that we can see how we, using one of the columns. So to plot a scatter graph plot to visualize the relationship between the weight of the car and the miles per gallon, which is the MPG. So we say empty cars.plot. What kind of plot is scatter? The X value is weight. The Y value is miles per gallon. The figure size is 9.9, and the color is black. Now let's go down and see. Now what do we have here? We have that, let me scroll down a bit so we can see it. You can see how it works. Now we notice that what? As the weight, this is the weight of the car. As the weight of the car increases, the miles per gallon drops. The miles per gallon. That means that the heavier the car, the slower it becomes, and the lesser miles it covers per gallon. So that is what this scatter graph shows us. Now, how do we use this model? Now, what do we do now to create a linear regression model? What do we do? We have to import this library from Python. So say from sklearn, import linear model, sklearn, then to initialize the linear regression model. This is what we use. You can use any name here, but we'll just use regression model equals to the linear model dot linear regression model. Linear regression model function. Then to train the model using the empty cars data, now we say linear regression model dot fits, which is the line we want to fit, or the x values and y values we want to fit. So x dot pd dot data frame as empty cars. We are training the x values with the empty cars. Training the values, that means we are testing the values given to us using empty cars data of weight. We put it under x. Then the y value, we use empty cars dot miles per gallon. Then we make progress. So check the trained intercept, y-intercept. What does y-intercept mean? For those who don't know, is the mean value of y and the value of x. The mean value of y where the value of x is equals to 0. Or simply said, the value, let's leave out the mean value. Let's say the value of y where the value of x is equals to 0. So that is what is called the intercept. How do you get the intercept? You print it. You say regression model, which is this one here, dot intercept. Then you put this underscore here. Then we also check the trained model coefficients, which is the amount y changes. The amount y changes for every unit of an increase in x. That means for every time the weight increases, to what level does the y, which is the miles per gallon, depreciate? To what level? So by the time you to print that or display that, you say print regression model dot coefficient. Now by the time you run this now, you see that the intercept is 37. That means the value of y when x is equals to 0 is 37. Then the regression coefficient means it at every time there's an increase in the weight, the y changes by minus 5.34%, or minus 5.34. So that's what it simply means. Now let's make progress. Okay. Now if we make progress, check here. Now to determine how well the model fits the data, we use the regression model dot score. That's how you determine whether how good your regression model is working. Equals to PD data frame empty cars, then y is equal to empty cars mg. When you run this model, you discover that the score is 0.75%, meaning that what? It fits it to a very great level. So your model, it's a good model. That means, but if it's lesser than 5.0, that means the value of the model, the value of your prediction will not be very accurate. So now it's telling you that it is 75% accurate of your predictions. Now let's give a visualization of the linear regression model. So how do we do that? We use to train the model with the data set. You say train prediction equals to regression model dot predict x data frame. Now remember we used the train model. This is the train model to get our graph. So we are just repeating it here. Wait, then to plot the scatter graph. Now this is the plot of the scatter graph which we did before. Now we are using the train model is the train model, what we want to see for the x-axis. We said train regression model dot predict x equals to PD data frame empty cars dot weight. Now to plot the line. So say we plot PLT plot. We use this value at the beginning. We loaded it into a library from the library into PLT.plot empty_cast.weight train prediction. So this is the train prediction, which means we want to find out the values of the prediction line, predicted variables. These are the predicted variables based on the values that we have trained the X values with from the data set, and the color is blue. Then if we run it now, this is the code. We run these values now. If we run it, when we run these values now, you discover that now this is the line. The former one was a scatter, which we knew before. So the best fit based on the values, the predicted values, are this line. Now, what does this mean? Let's take a simple example so we can understand now. Let's assume that we have a point here, which is on 4.5, which comes to this value here. Now, the best predicted value for this 4.5 will be you take it straight to the y-axis. It should be around 13 or 14. So the value of 4.5 weights, the miles per gallon, if I go straight properly, it should be around 13 or 14 miles per gallon. If you take another value, let's say 5.0 here, you take the value 5.0, the miles per equivalent, the predicted miles per gallon could be 10 or 10.5. So this is how you use the linear prediction model. Now, there are other prediction models in Python. Now, it depends on what you are looking for or what you want to achieve in your analysis. So this gives you a fair view of how you can use a prediction model in Python. So I hope you have learned something from this lesson. So if you have any questions or any areas you want us to still cover, or you have anything that you have observed, please feel free to drop your comments. For all that, my name remains Vincent Hope.